Don't get too pissed off. I'm going to try to justify why I'm saying them. Oh my, lions, tigers, and bears. All right, let's just jump into it. I got a demo to run. It takes a little bit of time. I'm going to start. Why can I throw these up there? All right, I'm going to start 2 VMs. This demo is kind of canned. There's no way you would be able to take VMware UEFI and like throw a Trojan into it. So I've Trojaned it beforehand. I'm going to just show you the power of what you can do with some UEFI Trojans. I have 2. One is Trojanized, the other isn't. I'm just going to, oh shit. No, I need to reset this guy. All right, so both of them being Trojanized, or one being Trojanized, what you do is kind of like just run into the VMX file and say, I want you to run a custom UEFI. So you just put firmware, you want it to boot EFI, and then you say the actual file name for it, and I'll get into what you do with that in a little bit. These are Windows 7 SP1. I tried Windows 8 Pro. I have a Metasploit, the interpreter, as the payload. And 8 kind of grabs that and deletes the file, so you use something like a Veil framework to fix that. But so SP1, just for now. Objectives of this talk, I want to do that data science crap where people like Dave yell at me for saying buzzwords. How we can use that for evil, you do a lot of defensive work. Show you how you can do that for like offense stuff. Enable all of you guys, researchers out there, to find vulnerabilities in this kind of stuff, and also introduce UEFI BIOS pen testing. There's a lot of like abstract proof of concept talks out there. Let's make this real. If you walk into an engagement and you tell like a vendor or customer, hey, you need to secure your BIOS, you need to secure your UEFI, let me show you how I can put a Trojan into it. And also, like, let's have some fun. So just keep track of where we're at throughout the presentation. My wife likes to call UEFI UEFI. So I don't know if you've ever played Final Fantasy VII, but I think that's a cool way to say UEFI. All Windows 8, like if you see a logo on it in Best Buy, it's supposed to support Secure Boot too. So when people talk about UEFI, that's like one of the biggest problems that they have, or one of the biggest things that they love about UEFI is this concept of signing firmware updates, checking SHA-1s, having like PKI inside your BIOS. So when a vendor gives you a new update, you can make sure that it really came from that vendor. To comment on that, like Yuri from Intel, goes through this entire list of things that should be inside Secure Boot, and there's just a bunch of checkboxes. So vendors implementing Secure Boot, trying to get that Windows 8 logo, they're just following a list of checkboxes. I went into Best Buy last week, and I went to all the demo machines that they had up there, all with Windows 8 logos, and I checked to see if they supported Secure Boot. So if they have the logo, they should support it. Like 2 of them had Secure Boot turned on, 50% of them supported it, the other 50% I could not find for the life of me where in BIOS you turn on Secure Boot. I'm not going to say that they don't have it, but I couldn't find it. It's also a lot of fun too when you're walking into Best Buy, like checking the BIOS and the guys come up like, hey, you want to buy this machine? No, fuck no, I don't want to buy this machine. But I'm going to screw with the BIOS a little bit, So also every OEM right now should support UEFI, so I'll get into that in a little bit. This is like a canonical slide that you have to show if you're going to talk about UEFI, and this is pretty much like the workflow of UEFI. Get some stuff started, do some driver initialization, board initialization, chipset initialization, run a bunch of services like enumerating more drivers and crap like that for the board. Try to find what devices have bootable capabilities, and then load UEFI applications from those devices, which will then bootstrap your operating system and run. Then there's this red thing out there, which is like runtime services, but no operating systems support that right now, which is, hey, once you bootstrap from firmware, you can still run stuff from firmware land when you're in your general purpose operating system. I don't care about that crap though. You'll see there's some like UEFI boot kits out there, which like Dream Boot, which will replace the boot manager for Windows 8, Windows 7, or like something like Grub, and it'll try to like subvert the kernel by running after the boot device has been initialized, scanned, and then applications run from it. So just kind of focus on this stuff for right now. This is like the stuff that is in Flash. How do we attack that, but also get persistence on it? So I don't care about like the general purpose operating system or any UEFI drivers that run there. So really cool thing, from Intel in the UEFI forum, there's a format for how you package, update, and run UEFI code. Thankfully, all the OEMs and independent service boards, they will take that and they're like, yeah, that data structure isn't really what I want to do. That int 32, yeah, I'm going to make that a short. So they just kind of do it themselves for the most part. So I kind of, similar to JDuck, I wanted to know how often that happens, but also, when I'm canonically talking to someone saying like, yeah, I can put a Trojan into UEFI, they're like, yeah, but you can do that for one board. Like, yeah, okay, yeah, I've only tested it on one board, but I want to know how often that works for other boards, other vendors. So kind of the same thing as a Droid Army. I kind of wanted to grab every single UEFI update, every single bit of UEFI x86, AMD 64 update code out there. So I wrote this tool called UEFI Spider, which I'm going to release like as soon as I get out of here and get back up to my room. That'll crawl all these vendors' websites and download the UEFI update. So the guys that I support right now, I try to get like the ones that have the most UEFI updates. And also while I'm spidering that, I'm grabbing the release time of the update, if they assign like some criticality, so like this is major, this is normal, this is critical. And if they put patch notes in there too, this tool will grab all of that. Afterwards, I have a slide on it. But so what does it grab? For the Optiplex 9020, it's a Dell machine, you'll get something like, all right, there's A0 through A7 with a missing A6, and you'll get the update times for each one. And you can look at cool things like, hey, this was 5 hours apart. Why the hell did a vendor release an update for BIOS 5 hours after they just released one? Like, what the hell? Also with Dell, they're the kindest update vendor out there. They release the exact minute and second that they release the update. Everyone else is like, yeah, here's the day I updated the BIOS. And also, like, what happened to A6? Why are you going from A7? It's probably like something internal. Lenovo likes to do that too. So afterwards, there's a fuck ton of updates that I get. So here I put like feeling, like how I felt after I wrote the Spider. Lenovo, if anyone here works for Lenovo, or if there's anyone listening, or like, after this gets replayed on the internet, if you work for Lenovo, I feel really bad for you. Your data management system sucks. There are so many like edge cases when trying to parse your web pages and trying to download your updates. I have no idea how you manage that many systems. But so there's a lot of data out there, a lot of UEFI code. While I was scraping too, I found, I'm not going to say who I found it in, but a null pointer dereference. I didn't look at the coverage too much, but I was pretty sure I could inject code into their website. So, I told them about it and they fixed it. So not only does Lenovo suck, but like these vendors, when just trying to crawl updates, you can like find crazy shit on their web pages. Yeah. I'm sorry, Lenovo. I'm just going to call you out. So afterwards, there's 54 gigs of UEFI updates. Taking that and throwing it into a database and like removing all the update mechanisms, like the flash binary that gets packaged with the exe that unpacks itself and then uses it to throw it into the SPI. Like I call that like deduping. After I dedupe it all, I get 21 gigs of UEFI code from all those vendors that I just mentioned. All right, so where are we right now? We have all the UEFI. So we have all the UEFI code now with that tool. If you're going to run that tool, I would be careful. You're going to need at least 54 gigs of space on your disk. Also, be careful of the end user license agreements. Read them before you use the tool, right? So what's inside one of those updates? There's these like massive layers of abstraction for the code, and you can there's something called a capsule, and there's firmware volumes inside that, and then there's like arbitrary file systems within that, like NTFS. Most of them are this Tiano or EFI firmware file system, but inside that, then there's files. Sometimes there's encapsulation, like compression. EFI has its own compression mechanism, which is actually 2 versions, and the bit that's supposed to tell you what version it is isn't always the same. It's pretty much just Huffman encoding. And then inside those files, you get like these paddings, you get Intel's MEBICs, you can get IMT drivers, Trojans, or power management configurations, microcode for the CPU, or just like general purpose UEFI applications and other crap. And there's various mechanisms for signing code and doing secure boot. One of them is like in each one of these files that's inside the update, you can put a flag that says, I want to sign this. Here's the SHA-1, or here's the signature of it. So it's like you're flipping a bit, telling me or telling the board to check the signature of this. Well, I'm just going to change the update and throw it in without that bit set. And then does that mean that you're not going to check the signature of it? So I can just inject arbitrary data there. So this is I'm kind of divulging into some of the questions that I wanted to ask by doing this. So how do you get all of that data out and parsed? Well, I have another tool called UEFI firmware parsing. This is not something new. This is just like my take on the tool. There are great tools out there already that will parse UEFI. My tool, I guarantee you, will parse every UEFI file or update that comes from all those vendors that I listed, because I check them. And there's tons of edge cases inside there that makes sure it parses each one of the updates from those vendors. So I have a couple other capabilities inside that tool too. This is like, I wanted a one-stop tool. It's a Python module, so you can like include it from your offensive tool packages or distributions or whatever you have right now. Extract everything, show it on a console, but also inject and replace various parts inside the UEFI update. So it kind of comes out as something like this, where you see, all right, here's the tree of data structure that's inside the update. Then if you want to inject something, you kind of can visualize the structure, but use the same tool to say, hey, this is the GUID, this is what I want to replace, here's the thing I want to replace it with, and then how do I output that? So if you wanted to inject a Trojan into your UEFI update for a various system, this is kind of the tool that you would use. That's kind of my hope for it. All right. So there's also this like there's P32s inside, which is just the UEFI form said, hey, that encapsulation mechanism for running code, we kind of liked it. I don't know why they picked PE, but so they take all their code and they throw it into a .text section for a PE, and they throw that into the update. It makes it super useful for us to go through and parcel that too, because you get this nice PE file where you kind of enumerate all the portions of it and just extract the assembly code if you want to compare it, or if you want to fuzz it, or if you want to reverse engineer it. The only kind of caveat there is in something like what I'm about to present in a couple slides is if you're comparing all this, if you're treating it as raw data, like there's a compile time inside of it too, but a lot of the code is not position independent. So if you're comparing two updates, like for the Dell 9020, they might not change any code, but if they recompiled the whole thing, all the subroutine offsets are going to change. So you kind of have to go through this and say, hey, where's the physical address of the code that you're releasing, and let me kind of like normalize that across all your updates, and then start comparing. The timestamp too is really cool. If you go through and look at the vendor pages and say, hey, when did you release your UEFI update? All right, when did you compile that? You get really, really wacky things. So, and this allows me in this tool too to get a really precise time on when this update was released. And I'll show you what I can compare that to. So, There are other tools out there that kind of do the same thing for other like benign purposes. If you want to run a Hackintosh, you have to change the power management configuration inside your firmware updates. Or if you want to pirate Windows, you inject a slick config. You put like an OEM released a Windows. What was it, like the key inside the BIOS? That way, every time you install Windows again, you don't need to put in a key to activate it. So people use this. There's tons of forums out there where I will say, hey, I really want to pirate Windows. I don't really know what I'm doing. Can someone give me a pirated copy of the UEFI firmware for this board? And then someone else, whether they're malicious or they're just a good citizen, will say, yeah, here's the update. Download this and flash it to your board. Yeah, I don't know if I trust that. So what can we do at this point? We can get all the vendor-specific implementations of UEFI, reverse, grab all the assembly code out, and then identify portions that are not signed. So let's keep going farther. And for this, I'm going to introduce like a cool concept that I kind of came up with because I don't know, I need something to entertain me while I'm sitting there like coding. So protection domains, the traditional 0, 1, 2, 3 that we give to kernel land, user land, device drivers, although like 0 and 3 are the most popular. Everything below that, the really awesome guys that throw out vulnerabilities inside UEFI have come up with like -1, -2, -3. So if you see some of the papers from Invisible Things Labs, that they call them -3 or ring -3 vulnerabilities. So I kind of want to group all of that together and call that sub-0. So every ring that comes below 0, because we're going to invent some more, -4, -5 are down the road. So call all this like -0 land, and then the scariness of -0, or the scariness of the ring is just that times -1. So the lower you go, the scarier it gets. And then that's Intel Management Engine, which they called -3. So we call it scary too, because like Sub-Zero is wicked, awesome, scary guy who'll just like rip the head off someone and grab their spinal cord with it. It's pretty scary, man. If you met this guy, I'd run. So what's scary about that is like the attack surface is huge. You have these weird unsigned data OEM provided headers where they throw in logos, they throw in all this weird crap that's not checked. It's not in the reference specification for UEFI. You have all this useless crap that's running in the firmware of your board, like games. So MSI throws games inside your firmware. So what are you doing? Like trying to install Windows, and you're like, yeah, you know what? I just want to like shoot some stuff before I boot. Yeah, that seemed like a good idea. They have, you can browse FTP sites inside there. You can browse your NTFS file system, assuming you're not, encrypting it. You can do non-TLS, non-SSL updates of the firmware from within the firmware. You can, have these weird, wacky animations running inside there. But it's just like, why? Why are you putting this stuff inside firmware? I understand the network drivers, but like UPnP, what are you doing inside firmware that you really need all of this useless code? That's just adding to the attack surface, as well as giving you like one feature that you may not have wanted. But also, there's a bunch of different ways to do firmware signing and do secure boot. So us, as security researchers, looking at the reference specification, looking at all the stuff that the UEFI forum puts out there, you can see it, like you can track it month to month and watch the changes. So being able to audit whether the vendors are conforming to these implementations, whether they're adopting them, or whether they just don't care or they're messing things up, that also adds to the attack surface. Like I'll just give one example. So secure boot enable bit, it's a bit inside Flash that says, do you want to turn on secure boot? Okay, cool. When the operating system is booted, you probably want to disable write access to that bit. That doesn't happen, yeah. Well, I mean, it does happen for a couple vendors, but not all. So, all right, so here's the crux of what I'm talking about. So I have this other tool called Sub-Zero, right? All right. So that takes in all the output from UEFI Spider, and it gives you a web browsing interface, so like this web UEFI, or this web UI for browsing all of UEFI and inspecting each one of the updates. But it also is this platform for vulnerability hunting inside UEFI. So you can compare each one of the updates, see what code changed. You can compare it across vendors, across platforms, and really kind of like dive. So isolate if vendors are changing bit protections, if they're changing previous announced vulnerabilities. So what can we kind of do with that? We want to find things like this, like a 1 day, right? So a 1 day inside firmware is much worse than a 1 day from Microsoft, because the chances that that firmware is going to get updated in 5 hours is like very low. It's only happened once, but the chances that it's going to get updated in half a year or 4 months, very high. So here's the example 1 day that we're kind of looking for, which is the vendor added 2 subroutines. Here they're changing that secure boot enable registry value. The registry inside the UEFI in this context is actually just mapped to some SPI flash and VRAM location that says, hey, do not write this from here on out. So previously, before this, anytime during operating system run, you could change that secure boot enable flag to be off. So if you get root on that system, you can turn off the secure boot, you can inject your own firmware, and then you could persist down there. So some of the stuff that MITRE's released over the couple of years, like Tick and Flee, completely applicable to this. So how do we find these things, and then how do we scale them across all of the UEFI updates for platforms and vendors out there, right? And do you get like Sub-Zero hell? It's like 1 day from hell. Okay, whatever. So the other thing that's kind of screwy about this is, like I said before, if you have non-position independent code, these subroutines always change, but then also the places inside Flash that the vendors use for that secure boot enable bit will also change dramatically. So not only do you have to kind of find these write protections across all the updates, but you have to normalize all the places in SPI Flash that they're going to be changing. And then, most of the releases in UEFI are just to like add crap, like support for new operating systems, support for new drivers, video cards, and that kind of crap. So you have to isolate all that out. So some of the things that you can do in this platform, I'm going to talk about 4 of these. They're kind of the funnest and easiest things to talk about up here in the 15 minutes that I have left. So memory manipulation. So if you look at UEFI's, the reference specification, which is called Tyano, and it's available on GitHub or it's available on SourceForge, you can see the entire API and go through and say, hey, what part of this API is doing memory manipulation? All right, let me take that code, which is available in source code, compile it, and then come up with something similar to flirt signatures for that compiled version of that API call. And then let me also grep through the entire reference specification of how many times you use that. So then I can take that and go through Sub-Zero, which is this big analysis platform, and say, how many times do I see this kind of flirt signature of memory manipulation throughout all the updates? And how many times do you change that memory manipulation? I'm looking for people abusing that memory, but also trying to fix bugs with memory. And that's pretty easy to do in Sub-Zero. We have Elasticsearch on the back end. We have all the disassembly in like text form. So just searching for the flirt signature across all updates is like a 40-second operation. The other thing that we can do is like that 5-hour change, and that was Dell before, that changed the firmware in 5 hours. We can look across all the updates and say, how quickly are you updating firmware, and why the hell are you doing it so quickly? So here's a top of the most recent, or the fastest firmware update. So you see Dell with the update VNHYR, which is just the canonical name they give to the update, updated in 5 seconds. So they released an update and then they released another one. Actually, it was the same update. They just kind of messed up. But Going down a little bit farther, you can see things like, all right, if I'm updating within a couple hours, like that's where I'm going to start targeting for my vulnerability. You can also compare this to Tyano. Tyano, like it's all in Git and SVN. You can look for vulnerability announcements, but also bug fixes, and then compare that to the firmware release times for each vendor and say, like, how fast did you uptick this vulnerability, this patch? And then we can also look at small updates too. So if you're updating just a small bit of code, I want to know why you're taking the time to release an entire firmware update for just 465 bytes of code. There's probably a vulnerability there. So we can kind of graph these updates too with D3 inside Sub-Zero, and we can say, all right, let me look for a time where Dell or HP or Lenovo or the other vendors that I mentioned update their entire corpus of products. Why are they updating their entire corpus of products within a 2-week time span? What's going on there? Hopefully they're releasing some code to support a new video card that just came out, but for us, hopefully they're also patching some vulnerability. So let me check to see the vulnerability that they patched and make sure the other vendors are also patching it too. It doesn't happen. So this is actually a snapshot from Dell, and around that time, and we can also do something like compare this to security announcements at like DEF CON Black Hat and watch, all right, there is a specific product that they targeted, the researchers targeted, and they released a vuln for, and Dell patches that in the next week. All right, awesome, right? But chances are every other product that Dell has also introduced that vulnerability before, and did they patch those too? So we can visualize those things here. We can also look at, and I guess my labels got cut off. So on the y-axis, this is the amount of code changed. On the x-axis is how much time was lapsed, like the delta in time between the change. So we can look at things that were massively changed or things that very seldomly get changed. And then in the Sub-Zero interface, this is D3, you can click on one of those and then it'll bring you up to the update and show you all the changes that happened. So the other here, let me see if my wireless is working. I can kind of show you that. So this is the D3 interface. It's just a Rails app. Going through, let's hit Explorer, see if my, no, wireless isn't gonna hit it. All right, never mind. But so clicking each one of these two will kind of bring you into that layout of here's the firmware update, here's the encapsulation mechanism, here's the file that was included, and then here's the .text section, and you can download all that too. Let's go back to Keynote and play all that. So another really cool thing is when I said I was scraping them all from the UEFI spider, you can grab the patch notes and like criticality labels. Like how often do you think a vendor puts critical next to a firmware update? It's not very often. So when they do that, we can grab that and say, all right, let's open that up and look exactly, and then compare it to the firmware release before that and say, what did you change that prompted you to put a critical label on your firmware? So, I have a little interface that goes through all the updates and it looks for these special words like critical, like security, like secure boot, and it brings all those updates right to you and says, all right, here's the size of it, here's when it was released, and then, obviously a link to go in and inspect it. So, things that we want to look for are kind of, hey, I want this update that happened in 10 of 2013. Let me look at that. Chances are that there's still some attack surface there that I can try to RE and exploit. Yeah, so look through the patch notes too. If you ever see like enhanced biosecurity, chances are they just fixed secure boot enable write protection. And let me jam through this too. So if you were to click through, I kind of hid some of the vendor in this case, but for each one of the files or for any type of data inside UEFI, you get for how many bytes changed, the percentage, and then how many other vendors or products also share that file. So if you wanted to scale an exploit for UEFI that you tested and targeted for a specific product, now you have in this case, 450 other products share this same piece of code. Now you can scale your exploit across all of those products, right? And you can get a nice list of all the products that exploit will support, right? All right, so at this point with Sub-Zero, you can pinpoint, isolate, identify these like one-day vulnerabilities through all those vulnerability analysis tools that I just mentioned. And you can also isolate like the security-related UEFI code changes. So if you are targeting for 1 day, you can kind of pinpoint and go right to the code that the vendor's changing. If you're trying to do vulnerability analysis or exploit development. So the last part that I have right now in Sub-Zero, and I'm actively developing, I'm going to keep going for a couple of years on it, is look for like the most used application. So if you just kind of sat down and you're like, hey, I want to develop a UEFI exploit, what should I target? Like what code base should I target? You can see, and this gives you a better idea, like out of I have 3,300 updates inside of the database that I'm using right now on my machine at home. There's this one GUID, which is a file inside the update, that is shared amongst 3,018 updates. So that's a pretty damn good place to start targeting. If I were to find a vulnerability there, and if I were to weaponize it, then I could get coverage across 3,000 machines. I'll back up here because I'm going to start talking about a little bit of like what the fun that you can do and some of the fun that I've had with the pen testing concept of UEFI. I saw that like 468 machines across 3 vendors include CompuTrace inside UEFI, and it's not signed, so there's not the bit on there that says, hey, this Trojan that I'm going to inject into your firmware update, yeah, can you please check the signature on that? Because if someone changed it, it'd be bad. They don't do that. So what does that look like? There's a lot of analysis of CompuTrace, of absolute CompuTrace from like the malware perspective of once it gets dropped onto your system. But if I wanted to look at like what happens in firmware land, so the first thing it does is it's a UEFI application that runs inside UEFI. I'll give you a little perspective of this. Every single one of those GUIDs that I just had up on the screen, if it's considered a driver, then it's going to have a dependency expression that says, here are the drivers that I want you to load before me. Once that dependency is met, then the driver runs. So if I include a driver inside UEFI that enumerates NTFS, or enumerates partitions, parses NTFS, and then drops something on the file system, it's going to run as long as like the dependencies were met. And the dependencies there are like, hey, give me some disk space. So once I have some disk space, let me see if it's NTFS. So that is essentially a UEFI application that parses all the file systems, all the partitions, all the file systems. It looks for Windows System 32, and it looks for an application on the NTFS partition called autocheck.exe, which is the tool that just kind of scans your file system. It runs in before Win32 mode, and it checks to see if like your file system was marked as dirty. If it is, then it goes through and tries to fix your file system. So CompuTrace looks for that, and if it finds it, it'll then inject, it'll replace it. It'll replace it with 22K of a dropper, and it drops this file called rpcnetp. So now the tool that was used to check your file system is replaced with a dropper that just kind of phones home and then downloads the real CompuTrace. I'm like, all right, cool. This is in 432 UEFI updates. Let me just replace the code that it drops with like general purpose rootkit. So that's kind of pretty simple to look at like the dropper chain and say, all right, what do I want to target? The top two, so this is all running in UEFI land. The top two just check to see if you have a bit enabled inside your NV flash that says, hey, I want you to enable CompuTrace. So we just kind of get rid of that crap and focus here, which is, yeah, let me just isolate the dropper. Let me get the application code inside UEFI, and let me just replace and in this case it was the .data section, which contains the RPC net. So here's a tool that I also have inside the Sub-Zero, which does exactly what I just mentioned. Enumerates each one of the UEFI sections, looks for that dropper code, and then takes in your custom dropper and replaces it inside the auto check, and then writes that UEFI code back out with your custom RPC net P. So at the end of the day, you get this like nice little command line interface which says, hey, generate me a payload. In my case, I was using Metasploit, so I wrote a Metasploit module too that picks any one of Metasploit's payloads and throws them inside of this auto check dropper. So now with Sub-Zero, we have a tool. If we're going out and we're pen testing or we're vuln hunting, and you want to convince people to update their firmware, we can actually like throw a Trojan on their firmware. And I don't think I have time to run the update. But yeah, with this I have a persistence mechanism inside Metasploit that I'm releasing, which does just that. It lets you throw up a listener, and it'll go to Sub-Zero. So this is a really cool thing about Sub-Zero, and I'll throw this slide up too, is now that you have a database of all vendor UEFI updates, if you're targeting a system, or if you have a remote code execution on a system and you want to persist inside firmware, you can easily query the Sub-Zero database and say, here's the platform vendor that I'm on, give me the most recent update code, and let me then inject my Trojan payload inside of that and then flash the system with it. So you know that you're going to have a very, very, very low chance of bricking that system because you're grabbing an update designed for that vendor, for that product, and you're injecting your payload. So the scalability of injecting inside UEFI, of persisting inside UEFI, is simplified now with something like Sub-Zero that I can easily query. What I hope to do is eventually get that service running on Sub-Zero.io, where you can just kind of do that query yourself, and you don't have to maintain this 54 gig database of all updates yourself. I'm not quite there yet. So here's like the example. Here's where you would say the Sub-Zero repo that you would want to query. So for right now, you'd have to make that yourself and put in your local URL for that repo. So now where are we at? So grab all of UEFI, do all the vulnerability testing, do your exploit development with some general purpose tool, and then scale that exploit across all platforms, all vendors that's supported inside Sub-Zero right now. Inject your RAT, inject your post-exploitation tool, and have some fun. So afterwards, and the demo's kind of running. But I screwed up with VMware. But you should get an RPC net P dropped on the system with that Sub-Zero persist Metasploit tool that's created as a service. So as soon as the system boots, then RPC net P will run with your arbitrary payload. I got some questions from the Infiltrate guys, the immunity guys, of how big of a rat that you could throw in there, how big of a Trojan. Right now I only have it up to 17.5K. So if you have a Trojan that's that or less, yeah, you can inject it, no problem. There's definitely opportunity for larger payloads, but you kind of reach the ceiling of what code you can change inside of a firmware update without trashing the system or potentially bricking it. So reliably 17.5 kilobytes throughout all the payload, or throughout all the UEFI updates will kind of win for you. And then I have some to-dos up there to make sure that I pass. If you're changing code inside firmware updates, some of the vendors do have their own way to check for signatures to make sure that the size is the same, various CRCs that are sprayed throughout the update. So the tool that's in Sub-Zero doesn't check for all of that because it wasn't really needed with the stuff that I was checking. But Later, I'm going to start going through and profiling them and adding all that kind of stuff. So here's the three things that I'm giving you right now is the spider, enumerate all the UEFI updates, the parser that gives you the ability to inject various data inside the updates while maintaining those secure boot enable flags, and then also Sub-Zero to do that vulnerability testing, exploit development platform. And any questions? That's all I got, man.
All right.
Have you looked at Windows Phone 8? Because it also uses the secure boot, and once a jailbreak is found, making it persistent will probably rely on something similar to this. So I saw your tools go mostly for Windows 8.
Right.
But are you looking, and is there any way, I haven't even looked at this, to pull you at UEFI?
UEFI, yeah.
From the makers of these Windows Phone 8 devices?
Yeah, absolutely. So for the vendors that I have up there right now, I am pulling their mobile devices, also their application, their set-top boxes, and their general purpose applications. So they have like NASs, they have various other file store tools. And yeah, if I find anywhere inside their web pages that has any mention to UEFI, I pull that down and then I'll try parsing it, try brute forcing it for all the different UEFI firmware volumes, capsules, Intel's flash descriptors, all that kind of crap. Yeah.
Do you have Nokia or?
I don't. No. But realistically, it takes like a couple hours to like a couple days to write that new spider tool for a new vendor. So now that you mentioned Nokia and Samsung, I'll probably go home and write those too. Cool.
You didn't say anything about OS X. Does this work when you have Firewall 2 enabled?
Yeah, so I kind of steered away from OS X. Snare's done a lot of cool stuff there. There's no signature checking in OS X, but yeah, the firmware dropper, the stuff that I have inside Sub-Zero, if you have full disk encryption on, then yeah, that's not going to work. It'll bypass secure boot because it's going to change things that aren't in the secure boot chain of checking, but yeah, it's not going to be able to enumerate your file system if you're encrypting it. Absolutely, yep.
Who's next? We got another one?
This ain't really a technical question, but like you came up with the name Sub-Zero, or was that like from the Mortal Kombat game, or how did you come up with the name Sub-Zero?
I don't know, I just kind of threw it around. I was on a phone call actually with the MITRE guys, Zeno and Corey and John, and I was like, yeah, hey, call this stuff Sub-Zero, and they started laughing, and they're like, hey, you need to throw in a picture of, you know, Sub-Zero from Mortal Kombat doing like a fatality. I'm like, hell yeah, I do. Let's do it. So that's kind of the genesis, yeah.
Cool. All right, well, I hate to bar everyone from yummy food. So thank you very much. That was awesome.